So here we can see that there are, up till now, two ways of get an impression on what price you should go out in the market to present for the customers in order to create the biggest profit, the biggest contribution margin. And in the table, we saw the total and the marginal method. And in the diagram, we also found a solution. The last method I will show here is using the mathematics, and we will have to have an equation on those two lines called the marginal revenue and the marginal cost, because we know when they are intercepting, we'll have to stop increasing our sales. So the interception point where they have the same value, the same y value, is what we're looking for. And we have the equation of the marginal cost. That's quite easy because it will always be, in this case here, 25 at any value of x. So if we say that the marginal cost equals to, and we can say y equals to 25. The marginal revenue we can see that the marginal revenue, that's the one here, we can see that for every increase in the sales of 100, using the support points here, from 50 to 150, well, it is decreasing with 20. So it will be minus, we can say that y equals to minus 20 divided by 100x. But if x is 0, it will go through, well, we can see here it goes up with 20 for every 100, but I only need to go up with 50 or go down with 50 to reach a 0 from here. So if it goes up with 20, when it goes down with 100, then it goes down with 50. It will go up not with 20, but half of it, the 10. So it will be plus 140. And we can also check that, because if we go in and make this right click on a line, I can add a tendency line, and I can show equation on the sales. I can show equation on the marginal revenue, and I can show equation on the marginal cost. And here we can see that the marginal cost is indeed 25, and we can also see that the marginal revenue has the double slope, minus 0.2, has the double slope of the sales, and that's minus 20 divided by 100, so minus 0.2x. So if we put them equal, it will be something like 25 equals minus 20, or let's just say minus 0.2x plus 140. Yeah. And if I just change those two, it would be 0.2x equals, so I've added 0.2x on both sides, and I deduct 25 on both sides. So there will be 0 over here, and 140 minus 25 is 115. And to get 1x on the left side, I have to multiply by 5. So then I can say x equals to 550, 25, 575. 575. Okay. So, and that's also what we really expected, because we could see here in the diagram, it gave us a hint that it's intercepting at a point lower than 600. So now I can put the x into the price equation, because now I know the actual number of sales. It's not optimal number of sales. It's not the 600. It's actually 575. And that's what we have talked about earlier. Then this is, of course, not a dotted line. It's a full lines over here. It has all possible values here. So if I put that in the sales line, it will be y equals O minus 0.1 multiplied by 575 plus 140. So actually I could say that it's minus 57.5. So the price is y equals 140 minus 57.5. So that's 82.5. So now I've actually found in the mathematical solution, I have found that in theory, the best price is go out with 82.5 to expect a sale of 87.5. But of course, this is theory, but it's a technical way of finding out the area, the price, the best price in a market. So now that we have 3 different solution methods.